A telescope sitting 1 million miles from Earth just stared at a tiny pinprick of light 4 billion miles away and read its chemistry. Not guessed it, not estimated it, read it. Like reading the ingredients label on something the size of a marble from across an entire continent. And what it found on that frozen little world has completely changed what scientists thought they understood about how a planet can even behave. If you want to know what the most powerful telescope ever built just confirmed about Pluto, and why, researchers are calling it a genuinely new kind of climate that exists nowhere else in the solar system. Stay right here. And if you're new, subscribe right now because this channel covers real space science the way it deserves to be covered. No exaggeration, no clickbait, just the actual discoveries. Let's get into it. To really understand why any of this matters, you have to go back to the beginning, because Pluto's story is one of the strangest in the history of astronomy, and most people only know part of it. In 1930, a 24-year-old assistant named Clyde Tombaugh was given one of the most boring jobs imaginable at an observatory outside Flagstaff, Arizona. He photographed the same patch of night sky on different nights, then sat there flipping back and forth between the plates looking for a single dot of light that had shifted position against the background of fixed stars. Night after night, plate after plate. Most nights turned up nothing at all. Then, in February of that year, one dot moved. It was small, it was faint, but it had shifted position exactly the way a nearby object orbiting the sun would shift. That dot became Pluto. And Clyde Tombaugh, a farm boy from Kansas with no college degree, had just added a new world to the solar system. For the next 75 years, almost everything we knew about Pluto was a guess. It was too small and too far away to resolve clearly through any telescope on Earth. Astronomers could track its orbit well enough because that only required watching it move over time. But its actual size, its surface composition, whether it even had an atmosphere at all, these remain genuinely open questions for most of the 20th century. Some early estimates wildly overstated how large Pluto was, assuming it had to be big enough to explain certain gravitational wobbles in the orbits of Neptune and Uranus. Those wobbles later turned out to be measurement errors. Pluto had nothing to do with them, but the assumption stuck around for years before anyone corrected it. Then, in 2006, the International Astronomical Union held a vote. Pluto was formally reclassified as a dwarf planet. It became the only world in recorded astronomical history to be discovered, celebrated, given its own place in every textbook and classroom stir, and then officially voted out of the category that made it famous. That decision is still controversial today, but whether you call it a planet or a dwarf planet, what mattered was this. Very soon after that vote, we were finally about to get our first real look at it. New Horizons launched in January 2006, the same year Pluto was demoted. It carried instruments designed to photograph and analyze a world no spacecraft had ever come close to. And it had exactly one chance. No orbit insertion, no repeat pass. Just one narrow window of close approach, a few hours at most, before the spacecraft continued on into the outer solar system forever. After 9.5 years of travel, New Horizons screamed past Pluto in July of 2015 at more than 30,000 miles per hour. What it showed, the world completely rewired everything scientists thought they knew. There was a heart, an enormous pale region stretching roughly 1,000 miles across, shaped almost exactly like a heart, sitting slightly off-center on Pluto's face, smooth, bright. Strangely young-looking compared to the heavily cratered terrain surrounding it. Mountains rose almost 11,000 feet into a thin, hazy sky. Not rock mountains, water ice mountains. But at Pluto's temperatures, water ice does not behave like ice the way you know it. It is frozen so completely solid that it behaves more like granite. You could swing a sledgehammer at it and bounce off without leaving a mark. Planes of nitrogen ice spread across the surface in slow, churning cell-like patterns, suggesting that heat was still moving somewhere beneath the crust, which made no sense for a world that far from the sun, that small, with no obvious internal heat source anyone had accounted for. And above all of it, dozens of layers of blue haze rising hundreds of miles into the sky, catching the sunlight and scattering it into something that looked almost beautiful, almost alive. Pluto was not a frozen dead rock. It looked like a world still in the process of becoming something. New Horizons captured all of this in a narrow window of hours and then kept going. By the time its data finished downloading back to Earth, a process that took over a year given the distance, the spacecraft was already 1 billion miles past Pluto and accelerating away. There would be no going back. Whatever it missed on that single pass would remain a mystery, and there was plenty it missed. The biggest unanswered question was not about the surface, it was about the atmosphere. Specifically, the temperature of Pluto's upper atmosphere made no sense. Before New Horizons arrived, scientists had built careful models of what Pluto's atmosphere should be like. based on everything they knew about how thin nitrogen-based atmospheres behave. The JWST models predicted the upper atmosphere should sit at around 100 Kelvin. That is about negative 280 degrees Fahrenheit. Cold, obviously, but consistent with what you would expect for a world that far from the sun. The actual measurement came back at 65 to 70 Kelvin. That is 30 degrees Celsius colder than the models expected. For planetary scientists, that is an enormous gap. Something was actively cooling Pluto's atmosphere far more efficiently than any of their models had accounted for, and nobody could figure out what. For years, researchers studied the data, built new models, ran simulations. The answer would not come from New Horizons. It needed an instrument that did not yet exist when New Horizons launched. In 2017, a planetary scientist named Shi Zhang at the University of California, Santa Cruz, proposed an idea that many of his colleagues found almost absurd at first. He argued that Pluto's haze, those beautiful blue layers New Horizons had photographed, was not warming the atmosphere the way atmospheric haze behaves on Saturn's moon Titan. He argued it was doing the exact opposite. Zhang's idea was this: the tiny solid particles suspended in Pluto's haze were absorbing sunlight and then re-emitting that energy as mid-infrared radiation, not visible light, infrared heat. And on a world with an atmosphere as thin as Pluto's, that process was powerful enough to bleed heat away from the planet far faster than sunlight could ever replenish it. In effect, Pluto's own sky was acting as a radiator rather than a blanket, actively cooling a world that already had almost no warmth to spare. The problem was that nobody could test this idea. To confirm it, you would need to measure Pluto's mid-infrared emissions with extreme precision, and you would need TIAs of its largest moon, Charon, which sits so close to Pluto in the sky, from our perspective, that every previous telescope had blurred the two together into one messy combined reading. That problem waited 8 years for a solution. In December 2021, the James Webb Space Telescope launched from French Guiana and began its journey to a point in space about 1 million miles from Earth. After months of careful calibration, its instruments came online and scientists began pointing it at targets across the solar system and beyond. In May of 2023, an international team of researchers pointed Webb toward Pluto and Charon. What made this different from every previous attempt was Webb's mid-infrared instrument known as MIRI. It can detect light across a wavelength range from 4.9 to 27 micron S, exactly the part of the spectrum where Pluto's haze particles would be emitting heat if Zhang's theory was correct. And for the first time in history, Webb's much larger mirror and far more sensitive instruments were able to do something no previous telescope could manage cleanly: separate Pluto's infrared signal from Charon's. The technique involved carefully modeling Charon's own thermal signature, the heat that Charon itself was emitting, and then mathematically subtracting it from the combined reading. What was left was Pluto's own infrared glow, isolated and clear. When the team examined those results, something stood out immediately. The infrared emission coming from Pluto was stronger than what its icy surface alone could produce. The surface could account for some of the glow, but there was extra radiation coming from something above the surface, something in the atmosphere. That excess matched almost exactly what Zhang's model had predicted 8 years earlier. The results were published in the journal Nature Astronomy in June of 2025. The paper was led by astronomer Tanguy Bertrand at the Paris Observatory. The conclusion was clear: Pluto's haze is actively cooling its atmosphere, bleeding heat out into space through mid-infrared radiation. The upper atmosphere is genuinely about 30 degrees Fahrenheit colder than it would be without the haze. Researchers now describe this as a new type of planetary climate. Not new in the sense that it has never been theorized. New in the sense that nowhere else in the solar system we have actually confirmed is this happening. No other planet, no other moon, no other world we have studied operates this way. Pluto is not just cold because it is far from the sun. It is actively making itself colder, using the particles suspended in its own sky. Now let's talk about what exactly those haze particles are made of, because this is where things get genuinely strange. Sunlight reaching Pluto is roughly 1,000 times fainter than sunlight reaching Earth. Even at that faintness, ultraviolet rays still carry enough energy to break apart methane molecules in Pluto's upper atmosphere. When a methane molecule gets hit by UV light, it splits into fragments: a methyl radical and a hydrogen atom. Those fragments do not simply float away. They start reacting with each other. They combine into heavier compounds: ethane, ethylene, acetylene, gradually building larger and heavier molecules as they doctor ift downward through the thin atmosphere. Eventually, those growing molecules clump together into tiny solid particles, reddish-brown organic matter called tholins. Tholins are not gases. They are solid bits of complex organic chemistry, drifting slowly downward through Pluto's haze layers, scattering sunlight and giving the sky that bluish glow New Horizons photographed. They eventually settle onto the surface, coating it in a thin layer of frozen organic material. The James Webb Space Telescope has now resolved the presence and distribution of these compounds at a level of detail no previous instrument could match. Webb confirmed the presence of ethane, acetylene, ethylene, and carbon dioxide on both Pluto and Charon. Here's the part that should make you stop and think for a moment. Tholins belong to the same broad class of organic molecules that scientists believe played a role in the origin of life on Earth. Some researchers believe that similar chemistry, complex organic compounds raining down from an early atmosphere, may have contributed the raw building blocks from which life eventually emerged on our planet billions of years ago. On Pluto, this process has been running for roughly 4 billion years. A slow, quiet, continuous snowfall of biological building blocks settling onto a surface that is simply too cold for any of them to ever do anything. The chemistry of life, frozen mid-step. To understand just how cold that actually is, it helps to sit with the numbers for a moment. Surface temperatures on Pluto hover somewhere between about negative 387 and negative 369 degrees Fahrenheit. That is more than 250 degrees colder than the coldest temperature ever recorded anywhere on Earth. The record for Earth is around negative 128 degrees Fahrenheit, measured at a research station in Antarctica. Pluto is in an entirely different category. At those temperatures, nitrogen, the gas that makes up 78% of the air you're breathing right now, freezes solid and becomes snow. Methane, the main component of natural gas here on Earth, becomes a glacier. Carbon monoxide, which is toxic and deadly as a gas at room temperature, falls as crystals onto the surface. The very chemistry of Earth's atmosphere is the chemistry of Pluto's landscape, frozen solid. If you could somehow stand on Pluto's surface, this is what the experience would be like. The sun would still be visible, but only as an extremely bright pinpoint of light, far brighter than any star we see in our sky, but smaller than a pinhead held at arm's length. You could look almost directly at it. There would be no warmth, no glare, just a cold, brilliant point hanging in a sky that never fully brightens and never fully darkens. The ground under your feet would not feel like anything you have walked on before. Water ice at negative 380 degrees. Fahrenheit does not feel like ice. It feels like stone. It rings like steel when struck. The mountains rising around you, made from water ice, bedrock, and capped with methane snow, are some of the hardest terrain anywhere in the solar system. The atmosphere is about 100,000 times thinner than Earth's. There is essentially nothing to breathe, but that would not be the first thing that killed you anyway. The temperature would stop you long before the lack of air did. Overhead, Charon would hang in the sky, and it would never move. Pluto and Charon are locked in what astronomers call mutual tidal locking. The two bodies are so closely matched in size, Charon is about half as wide as Pluto, that they do not orbit each other the way the Earth and Moon do. Instead, they orbit a shared point in the empty space between them. The result is that Charon always presents the same face toward Pluto, and Pluto always presents the same face toward Charon. From the surface of Pluto, Charon would always be in exactly the same spot in the sky, always the same face turned toward you, never rising, never setting, just hanging there about 9 times larger than our full moon appears from Earth, slowly turning through a cycle of light and shadow over the course of 6.5 Earth days. 2 worlds staring at each other across 12,000 miles of empty space. And that brings us to the third discovery Webb confirmed. And it is the one that changes how we think about Pluto and Charon as a pair. Pluto is bleeding. Every second of every day, methane and other light molecules in Pluto's thin atmosphere drift upward to the very top of the atmosphere, reach escape foci, tie under the weak pull of Pluto's gravity, and disappear into space. Scientists had suspected this was happening for years, based on how thin the atmosphere appeared. What they did not know was where that material was going. It was going to Charon. The 12,000 miles between Pluto and Charon is not a barrier. It is a pathway. Methane molecules escaping Pluto's atmosphere drift across that gap, get caught by Charon's gravity, even though Charon has no atmosphere of its own, and freeze directly onto Charon's poles. Once there, solar ultraviolet radiation and cosmic rays hit that frozen methane and break it apart again. The fragments recombine into the same heavier organic compounds, the same tholins that coat Pluto itself. And over billions of years, this process has stained Charon's north and south poles a deep reddish-brown color that planetary scientists had noticed and puzzled over for years. For decades, researchers had a strong suspicion this was what was happening. The reddish staining on Charon's poles had to come from somewhere, and the most logical source was Pluto's own escaping atmosphere. But it was only a theory. Webb proved it. In papers published in 2024 and 2025, the same international team that confirmed the haze cooling effect also confirmed that Charon's red polar deposits are made of organic compounds that originated in Pluto's atmosphere. Methane stolen from Pluto, converted into complex chemistry, frozen onto a moon, a process that has been running for billions of years in complete silence. Nothing else in the solar system operates this way. No other planet is quietly painting its own moon using molecules siphoned from its own air. Webb also found something else on Charon's surface that deserves its own moment. In October 2024, a separate team, led by researcher Sylvia Protopapa at the Southwest Research Institute, confirmed the presence of carbon dioxide and hydrogen peroxy, D, on Charon's surface. Carbon dioxide is the gas you exhale. Hydrogen peroxide is the compound used in bleach and as an antiseptic on cuts. Both are sitting frozen on a moon billions of miles away, manufactured not by any volcanic or geological process, but by radiation hitting water ice on Charon's surface and rearranging the molecules into new compounds. When you add all of this up, the self-cooling atmosphere, the organic chemistry snowfall, the atmospheric bleeding, the painted moon, you get a picture of Pluto that is almost nothing like what scientists expected before New Horizons flew by in 2015. And it raises a question that researchers are now actively pursuing. If similar chemistry is happening on Pluto, complex organic molecules building up continuously over billions of years, could it be happening on other distant, cold, hazy worlds as well? The prime candidate is Triton, Neptune's largest moon. Triton is colder than Pluto. It has a thin atmosphere of its own. It shows reddish deposits on its surface that T looks suspiciously similar to Pluto's. And it has layered hazes that nobody has examined with anything close to the sensitivity Webb is now capable of providing. Webb has already begun turning its attention toward Triton. Results from those observations are still being analyzed, but the framework Webb established at Pluto, the idea that haze particles can actively cool a world's atmosphere through extremely-rare infrared radiation, is now a tool researchers can apply across the outer solar system. To Triton, to the moons of Saturn and Uranus, to distant objects in the Kuiper belt that nobody has ever examined closely at all. This is why the Pluto results matter beyond Pluto itself. For most of human history, the outer solar system was a blank, a collection of names on a diagram, points of light that moved across our sky in predictable ways and revealed almost nothing about themselves. We mapped their orbits with precision. We knew almost nothing about what they actually were. The last 10 years changed that. New Horizons gave us Pluto up close. Cassini spent 13 years at Saturn. Juno is still orbiting Jupiter, and Webb is now doing something none of those spacecraft could do alone, reading the chemistry of distant worlds without having to fly there. The mid-infrared detection of Pluto's haze cooling effect is not just a result about Pluto. It is a demonstration of capability. Webb proved it can isolate the thermal sig-Nael of a world 4 billion miles away, separate it cleanly from the signal of a companion moon sitting close beside it, and extract chemical information at a level of precision that changes what is scientifically possible. Every distant icy moon, every Kuiper belt object, every cold hazy world in the outer solar system is now within reach of that capability. Let's also step back and talk about what this means for the question of life. Not on Pluto, because nobody is suggesting life exists there, but in the broader context of understanding how life begins. One of the deepest unsettled questions in science is how the chemistry of life got started on early Earth. We know that roughly 4 billion years ago, Earth had a very different atmosphere than it does today. No oxygen, rich in methane, nitrogen, carbon dioxide, and other gases. Some researchers believe that organic building blocks, complex carbon-based molecules, may have formed in that early atmosphere and rained down onto the surface, providing raw material for the kind of chemistry that eventually became life. The problem is that on Earth, we cannot go back and study that process. The evidence has been overwritten by 4 billion years of geology, biology, plate tectonics, and atmospheric change. Pluto, in a strange way, is a working preservation of some of those early conditions. The chemistry happening in Pluto's atmosphere right now, sunlight breaking apart methane fragments, building into complex organic compounds, tholins raining onto a frozen surface, is a real ongoing example of chemistry that on early Earth ran its course and left behind only indirect fingerprints. Pluto gives scientists something they cannot get anywhere closer to home: a live, active, naturally occurring laboratory for prebiotic chemistry, the chemistry that comes before life, running in plain sight on a world we can now study in detail. This does not mean Pluto has life. At those temperatures, with that atmosphere, life as we understand it cannot operate. But the chemistry involved is not alien. It is the same class of organic chemistry that matters enormously when researchers try to understand where life on Earth came from. There is also one more layer to the Pluto story that Webb has not finished writing yet. Pluto's orbit is a stretched ellipse, not a circle. Its distance from the Sun varies dramatically over the course of its 248-year orbit. When Pluto is at its closest approach to the Sun, a point called perihelion, surface ices sublimate in the thin atmospheres. Rhe builds up slightly. When Pluto moves to its furthest point, aphelion, temperatures drop just enough that nitrogen in the atmosphere condenses directly onto the surface. The atmosphere literally freezes out. It falls as frost. You It can take decades or even a century before a closer approach to the sun warms things enough to sublimate that frost back into gas. Pluto passed perihelion in 1989 and has been moving slowly away from the sun ever since. Over the coming decades, its atmosphere will begin to collapse as the world moves farther away and grows colder. Some models suggest the atmosphere could freeze out almost entirely within the next few decades. Webb is watching this happen in real time. Observations from 2022 through 2025 are already giving researchers a baseline, a picture of what Pluto's atmosphere looks like now before the collapse begins in earnest. As future Webb observations track how the atmosphere changes over the years ahead, scientists will get something unprecedented, a real-time record of a world entering a centuries-long atmospheric winter. Nothing about this story should feel small. We are talking about a world 4 billion miles away that cools its own atmosphere using particles suspended in its sky. A world whose thin breath is being siphoned away and painted onto its moon. A world raining down organic chemistry that mirrors what may have happened on early Earth. A world whose climate is so unique that researchers have had to create new categories just to describe it. And all of this confirmed by a telescope sitting 1 million miles from Earth, reading light that traveled 4 billion miles to reach it, separating signals that previous instruments could never untangle. Clyde Tombaugh found Pluto in 1930 by staring at photographic plates in the dark, looking for a single dot that moved. He lived to see New Horizons launched in 2006, just months before he passed away. He never got to see the heart-shaped plane, or the mountains of water ice, or the blue haze layers that his small moving dot turned out to be hiding. But we got to see all of it. And now, thanks to Webb, we are seeing even more. The dot is not just a dot anymore. It is a self-cooling, moon-painting, organic, chemistry-producing, climate-changing world that has been doing all of this in silence for 4 billion years, waiting for an instrument sensitive enough to finally understand what it was doing. If this kind of real science content is what you are looking for, subscribe now and turn on notifications. Every video on this channel is built from actual published research. No exaggeration, no made-up mysteries. Just the universe doing what it does, which turns out to be strange enough without any help. Drop a comment below and tell me, does Pluto deserve its planet status back? Because after everything Webb just confirmed, that debate feels worth having again.